Welcome to this class. For today, we are to talk about the origin and structure of the Earth. This includes the universe, the solar system, and the Earth systems. Let's start! At the end of this class, each of you must know how to describe the structure and composition of the universe. Also, each of you can state the different hypotheses that preceded the Big Bang theory of the origin of the universe. You can also discuss the different hypotheses explaining the origin of the solar system. And lastly, define the concept of a system and also the subsystems. To begin with the lesson, let's talk about the structure, composition, and age of the universe. The universe as we currently know comprises all space and time and all matter and energy in it. It is made of 4.6% baryonic matter, or that comprises the atoms, 24% of dark matter, and 71.4% of dark energy. Let us differentiate the three compositions of the universe. Baryonic matter are ordinary matter consisting of protons, electrons, and neutrons, such as atoms, planets, stars, galaxies, nebulae, and other bodies. Dark matter also are matter that has gravity but does not emit light. These can explain what may be holding galaxies together for the reason that the low total mass is insufficient for gravity alone to do so, while dark energy are sources of anti-gravity. This can explain the observed accelerating expansion of the universe that will be proven in our next discussion. Hydrogen, helium, lithium also are the three most abundant elements in the universe. I know some of you are wondering how old the universe is. Well, the universe is 13.8 billion years old. It also has a diameter of possibly infinite but should be at least 91 billion light years. Its density is 4.5 times 10 raised to negative 31 grams per cubic centimeter. The universe is composed of galaxies. These are clusters of billions of stars. Clusters of galaxies also form superclusters. In between galaxies are just empty spaces. In a galaxy, stars can be found. These are the building block of galaxies. I know some of you are wondering what are stars made of. Stars are born out of clouds of gas and dust in galaxies. Instabilities within the clouds eventually results into gravitational collapse, rotation, heating up, and transformation into a protostar. A protostar now is the hot core of a future star. Stars can be categorized into two. The first one is the main sequence stars. In the core of the stars, hydrogen atoms fused through thermonuclear reactions to make helium atoms. One best example of this is the Sun, and these can burn their hydrogen gases up to 10 billion years. Another type of stars is under massive main sequence star. They burn up their hydrogen faster. One best example of this is the RMC 136A1 star, which is 300 times bigger than the Sun. You are wondering what will happen if these stars burn up their hydrogen. The remaining gas may end up as they are, or as planets, asteroids, or other bodies in the accompanying planetary system. Let's talk about the life cycle of a star. All stars begins to be a stellar nebula. For average stars, it will turn to be a stable star such as the Sun. Its hydrogen gas is being fused together to form helium, emitting heat and light. Eventually, all the hydrogen core is used up, and at this point, it begins burning helium in the outer layer. Due to this, the star expands, as is called as red giant. After this, it will become a planetary nebulae. The outer core starts drifting away, leaving a dense core behind known as the white dwarf, and eventually it will turn to be a black dwarf. In case of massive stars, it will turn to be a red supergiant, eventually forming a supernova. Supernova explosion disintegrate the outer parts of the star and outshine all stars in the galaxy. It will result to a neutron star or a black hole. A neutron star is a dense core left after a supernova, while the black hole is a result of the strong pull of gravity. I hope this will help. Many scientists are saying that the universe is expanding. One of them is Edwin Hubble. He announced his significant discovery of the redshift as evidence for expanding universe. Take a look at this illustration. Illustration A shows the position of the absorptions of lines for helium for light coming from the sun. In illustration B, he observed that spectral lines of starlight made to pass through a prism are shifted toward the red part of electromagnetic spectrum, toward the band of lower frequency. Thus, the inference that the star or galaxy must be moving away from us, and this is an evidence that the universe is expanding. Let's talk about this. A lot of you are wondering about the origin of the universe. Where did it come from? Well, we can explain that in two ways. According to non-scientific thoughts, and the second one is explained by science. Let's talk about the non-scientific beliefs. First is according to ancient Egyptians. They believe in many gods and myths wherein they narrate that the world arose from an infinite sea at the first rising of the sun. We also have the belief of the Central African people, and they tell a story of a creator god Mombo who alone in a dark and water-covered earth felt an intense stomach pain and then vomited the stars, sun, and the moon. According to Indian people also, there are gods who sacrifice Purusha, the primal man whose head, feet, eyes, and mind became the sky, earth, sun, and moon respectively. And lastly, the monotheistic religions of Judaism, Christianity, and Islam, claiming that there is a supreme being who created the universe, including man and other living organisms. Science also can explain the origin of the universe. Let's talk about the steady-state model. This was proposed by Bundy, Gould, and Hoyle. According to this model, the universe continuously expands as it maintains creating new matter, thereby maintaining its density. However, this was rejected because of the discovery of the cosmic microwave background showing the radiation in the universe. Another one is the Big Bang Theory. This postulates that 13.8 billion years ago, the universe expanded from a tiny dense and hot mass to its present size and much cooler state. Currently, this is the most acceptable theory on the origin of the universe. Let's check the illustration below. Let us see the difference of the two scientific origin of the universe. Steady-state model here shows that the universe is expanding as new matter is created, thereby maintaining its density. Big Bang model also shows that the universe is expanding, however having lower density. Unfortunately, steady-state model was discredited, and currently, the accepted origin of the universe is a Big Bang model. Let's talk about Big Bang Theory, as this was the accepted theory on the origin of the universe. From time zero, or 13.8 billion years ago, all matter and energy in the universe existed as a hot, dense, tiny state. It then underwent extremely rapid exponential inflation. After that, Big Bang nucleosynthesis took place and produced protons, neutrons, and atomic nuclei, also then produced hydrogen, helium, and lithium. 20 minutes after time zero, when sufficient cooling did not allow further nucleosynthesis, and that leads to the expansion of the universe. After 100 million years, the stars begins to form. Galaxies also began to evolve until such time that the universe continuously expanding and expanding. That is how the Big Bang Theory explains the origin of the universe. Let's also talk about the smaller scale features of the universe. Solar system is a part of the universe. It comprises the Sun, which is the centermost part, the 8 planets and the dwarf planets such as Pluto, satellites, asteroids, comets, and other minor bodies such as those in the Kuiper Belt and interplanetary dust. The Kuiper Belt, as you can see here, lies beyond the Neptune. The solar system also is located in the Milky Way galaxy. And we will try to see the characteristics of the solar system. We will examine their large-scale features and their smaller-scale features as well. Let's talk about the large-scale features of the solar system, which means that it talks about the characteristics of the planets as a whole. First, if you will notice, the mass of the solar system is concentrated in the center, which is the Sun. Also, all the planets are orbiting around the Sun, and they are an elliptical and are on the same plane. Nobody is on top of which. All planets revolve around the Sun as well. Their periods of revolution of the planets increase with increasing distance from the Sun. Of course, the innermost planet moves fastest, and the outermost are the slowest as well. All planets are located at irregular intervals from the Sun, so nobody is not following their orbit. No one is not in order. Let's talk about the distinct characteristics of the planets in our solar system. Most planets rotate prograde, meaning they move counterclockwise except for Venus and Uranus, wherein they retrograde. For the inner or terrestrial planets, they are made of materials with high melting points such as silicates, iron, and nickel. This made them rotate slower because they have thin or no atmosphere. They have higher densities and lower contents of volatiles such as hydrogen, helium, and noble gases. For the outer planets, they are also called as gas giants. They rotate faster. That is because they have thick atmosphere, they have lower densities, and fluid interiors rich in hydrogen, helium, and ice, such as water, ammonia, and methane. Those are the characteristics of the planets in our solar system. Talking about the solar system, let us see where did it begin or how did it form. There's a lot of rival theories that can explain about the origin of the solar system. First is the nebular hypothesis that was proposed by Swedenborg, Kant, and Laplace in 1700s. They thought of a rotating gaseous cloud that cools and contracts in the middle to form the Sun and the rest into a disk that becomes the planet. These hypotheses, however, fail to account for the distribution of the angular momentum in the solar system. It's because if you will notice this one, we only have one orbit here, and they fail to account for the other planets. Let's talk about the encounter hypothesis, which is the second hypothesis on the origin of the solar system. There are four scientists that supported this hypothesis. We have Boffins, James Jeans, Chamberlain, and Maltins. All of them believe that there are two bodies that encounter each other until such time that they draw gaseous filaments from both, forming into the solar system. Take a look at this illustration. From the two bodies who encounter each other, they draw filaments, forming into the inner solar system in the outer solar system. So that is how the encounter hypothesis is explained. Let's talk about the last hypothesis. This is the protoplanet hypothesis, and this one is currently accepted on all the origin of the universe hypothesis. According to this, about 4.6 billion years ago, in the Milky Way galaxy, there is a slowly rotating gas in the dust cloud dominated by hydrogen and helium, and they start to contract due to gravity. As most of the mass moved to the center to eventually become a protosun, and eventually become our sun, the remaining materials from a disk that will eventually become the planets and momentum is transferred outwards, forming a disk until such time that it became the solar system. It also mentioned here that high-speed collisions with large objects destroys much of the mantle of Mercury and also puts Venus in retrograde rotation. We've mentioned a while ago that all planets move counterclockwise. However, Venus and Uranus, they move clockwise. That is the reason according to this hypothesis. What is most exciting is collision of the Earth with large object produces the Moon. And that is the reason that our Earth has its Moon as its satellite. Now, as we tackle all these hypotheses about the origin of the universe, about the origin of the solar system, I know there's a lot of things that's coming into your mind. However, I just want to reiterate that these theories are based on scientific knowledge, and I know that you also believe in creation. So we are not forcing you to believe in this, we just presented the idea. So thank you so much for listening. See you in our next class.